Do not mark the attendance in the sheet which I have given you until and unless I say. Okay. Okay. And some of you, while marking your attendance, what you're doing is you are adding a comment onto the cell. So that would be not be taken as an this thing attendance. Okay, you have to type there as P. Okay, we'll discuss about it once we will reach it. Okay. So today we start the class. In the last class, we were discussing about the various parameters, isn't it? Like what do you mean by IP? What do you mean by BP? Isn't it? And FP, what do you mean by mechanical efficiency? How to calculate your thermal efficiency? And so many other things we have discussed in the last class. So today we'll be discussing 3 to 4 theoretical questions which keep on repeating in your question papers. So those are 3 to 4. One is heat balance sheet, different types of test, what we perform on the IC engines like motoring test. It might be Williams lines method, Morse test. So all those things we'll be discussing one by one today. So kindly concentrate. So heat balance sheet. By hearing the name, what do you understand by heat balance sheet? Anyone?
Oh, like
Foil like aluminum foil
Aluminium foil, okay.
for
Okay, it's
insulation.
more
Literally,
of
they'll use for insulation in VX.
isolation. Okay, it is something different, Lucky. What it is means, suppose you have a bank account with you. Okay, in that particular bank account, whatever the deposits you have done, whatever the withdrawal you have done, you can receive it in the
Not
form of an account
insulation,
statement,
essentially.
isn't it? Okay, so you can receive in the form of an account statement at the end of the month, isn't it? So that particular account statement will have all the parameters like whatever, how much amount you have deposited, when you have deposited, how much amount you have withdrawn, when you have withdrawn, all those details would be there in that particular account statement, isn't it? Correct? So similarly, heat balance sheet is nothing but the account sheet of an engine for its expenses and withdrawal of heat. Getting my point? Okay. Did you get this?
yes, sir. Yes, sir.
Okay. So as the bank account gives you the details of each and everything, heat balance sheet, what does it does? Suppose I have an engine like this. Think I have an engine. Okay. I have an engine. Okay, very good. So I have an engine like this. In this particular engine, so how much heat I have provided, what all this provides, suppose if I have provided 100 kilojoules of heat, this 100 kilojoules of heat, how the engine has utilized, how much it has been converted to power, how much is wasted, where it has gone, all those account balances would be given in the form of heat balance sheet. So this is very important practice that we make while calculating the performance of an IC engine. Can anyone just read this out? Anyone?
What, sir?
This one. Can you just read it out, Nishan?
Yes, sir.
Yeah.
A heat balance sheet gives an idea about the amount of heat utilized in the system. It gives useful information about the
Exactly.
performance of the engine. The heat balance calculations are done
Yes.
generally either on the minute
Minute
what's it,
basis
sir?
or the hour basis, isn't
Basis
it? So
or
heat
hour
balance would
basis.
okay. So heat balance calculations are done either in minute basis. That means per minute you'll be calculating the things, or you'll be calculating in per hour basis. So the typical heat balance sheet is being shown here. You can see. So all these things on the left-hand side, what you have is the amount of heat what you supply. Okay. So this is the amount of heat what you supply. On the other hand, on the right-hand side, whatever you have seen like this amount of heat which is being utilized, where it has gone, the amount of supplied heat, where all it has been utilized, that would be represented in this particular right side column. So according to you, this particular thing should match with this particular thing, isn't it? Then only you can achieve a heat balance, right? Am I correct?
Yes, sir.
Yes.
So yes, sir. So if you give you, suppose for example, I have supplied a heat which is of 100 kilojoules per minute basis. I am calculating, so it is per minute. E joule heat cooling water is somewhere around 15. 3 be the unaccounted heat, guys. Anyone could say this? What could be unaccounted heat? Are you able to see the screen?
Yes.
Yes. So if heat equivalent to BP, so I have supplied how much? 100 kilojoules of heat I have supplied. In those 100 kilojoules of heat, I have utilized 80 for BP, 15 for cooling water, and 3 for the exhaust gases. So how much is the unaccounted heat is my question. Any idea?
Two.
You calculate. Exactly, Ethan. So how did you calculate it? You have taken this particular value, 100 kilojoules, and you have matched this particular value. So this, if it is 100, even this has to be 100. So it is 18, 15, 3. It accounts for 98. Then remaining is 2. So unaccounted heat could be 2 here. Okay, got it?
Yes, sir.
So this is how we calculate uh, the various parameters which are there in the sheet. Okay. Okay. Now what you have to do, you have to calculate the heat supplied. So heat supplied is given by, I will just write once more here. It is already given, but I am writing it once more. So heat supplied is given by EMF dot into CV. So this is the formula to calculate the overall heat supply. Now, heat equivalent to BP is nothing but just BP. The value of BP indicates the heat equivalent to BP. So how do you calculate BP? You already know that BP is equals to how much? It is 2 pi NP by 60. So this is how we calculate the value of BP. Now, loss due to cooling water. So this is given by this particular formula here. QW is equals to MW. MW in the sense is mass flow rate. PW is mass flow relay water. POW is temperature out and temperature in. Okay, suppose if there is an engine, so hot water would cool water would enter. Okay, and this particularly cools the engine and returns back, isn't it? So what is the temperature at this particular point is T inlet, and what is the temperature at this particular point is T outlet. So this is how you calculate the heat loss due to cooling water. Next is heat loss due to exhaust gases. Again, mg is mass of the exhaust gas which is going out, and Cp of G is nothing but Cp of the exhaust gas. Again, TGE and TA. TGE is the temperature of the exhaust gas, whereas TA is the ambient air temperature. As you have calculated just now, you have given me the answer as 2. How did you do it? You have done 100 minus of 80, 15 plus 3, isn't it? So that is what you have done to calculate the value of unaccounted heat. So unaccounted heat is given by heat supplied minus whatever you have consumed. So that gives you the value of unaccounted heat. So as you have just said, similarly, it has been given in the form of formula, that's it. Any doubts in these calculations? Anyhow, we will be solving plenty of problems on this. Any doubts in these calculations and the heat balance sheet? Any doubts, guys? Good. So let me grab all this. Okay, this should be there. Okay, this will be there. Okay. Good. Now, even this is also not required, I guess. Okay. That's great. Guys, meanwhile, you start to mark your attendance. Okay, let me check the count. So one is already marked, I guess. Okay, I will just delete it. Now, start to mark your attendance within the next few minutes.
Sir, link.
No need to ask for the link. It will be already there in your Google Sheet. Okay. It will already save there. Attendance ATD is the file name. Okay. Complete the process fast. How many are there? Totally 47 are there. Last 2 minutes. Eight. Ritesh Kumar, kindly mark your own attendance. Don't go to Vishnu Raj's cell. Okay? Be at your cell itself. Ritesh Kumar.
Sir, is mine done? Nishan.
Even Abdul Rahim. Okay. Yes? Nishan.
Yes,
Let me
sir.
check. Nishan, yours is done.
Yes, sir.
ನಂದಾಗಿದೆ
Okay.
ಸರ್ ನರೇಂದ್ರ.
You have a... ಆಗಿರುತ್ತೆ ಕಣ ನಿಂದಾಗಿದ್ರೆ ಇಲ್ಲಿ ಗೊತ್ತಾಗತ್ತೆ. Don't worry about it. Okay? If you already typed it, it will be there. Don't worry about it. Okay? If you have doubt, I'll just present the screen also. Okay? You can check. Okay, now we can check here.
Hello, sir.
Okay. Shall we start and move on? Next particular method is the Williams-Lines method. So this particular Williams-Lines method is used to calculate the frictional power. So last heat balance sheet was used to just know the details of heat spent, wherever the heat spent to have the account of it, we had heat balance sheet. Similarly, this particular thing, which is Williams-Line method, is being used to calculate the frictional power. So how are you going to calculate the frictional power? It's very, very simple. What you have to do is you have to just vary the gross fuel consumption in your engine and the fuel consumption iruttalla. So just if this is an engine again, so you'll be supplying the fuel, isn't it, for this? Okay. Suppose if you supply 2% of the fuel, what is the amount of BP that you are getting? So brake power you have to calculate, brake power and the fuel. Okay. So you have to just make a tabular column like this, fuel consumption versus BP, correct? So for 2%, how much is the brake power you are getting? Suppose if it is 36 kilowatts. Increase it to 4% now. So if I increase it to 4%, so what is the amount of brake power you are getting? So 74 something. Like that you have to go on, tabulate the values, and these particular values, what you have to do, you have to put a graph. So while you mark a graph, okay, while you mark a graph, what happens? You have to join this. Once you have joined that particular graph, what you have to do, you have to proceed this particular line, which is a curved line, backward like this. You have to produce the things backward. Okay. Till where? Till it cuts the x-axis. Okay, till it cuts the x-axis. Now we have to mark the point where it has cut the x-axis from zero line on the negative side of the x-axis. Whatever the value will be there, that is nothing but the value of the frictional power. So this is how you calculate the stuff using the Williams-Lines method. Clear? Any doubts in this? It's easy method. Okay, any doubts?
No, sir.
Any doubts, guys?
No, sir.
Okay. Can anyone just read? I would just call upon Nagendra. Can you just read the limitations of Williams-Lines method? Since it has some limitations, what are those limitations? Yes.
The
Read
octane
it out.
graph may be not straight so that it can be extended backward. Error are more since extending backward may not be perfect.
Yes. So one second. Perfect. Wait a minute, Nagendra. Okay. See, first of all, to extend backward, this particular line is not straight enough, isn't it? So definitely there will be some error. So you cannot predict the curve. So how it goes, isn't it? You cannot predict the curve. If it was a straight line like this, it could have extended properly with a greater accuracy. But that is not happening. Since it is a curve, there would be some errors. And extending backward also, you need precision for that. Any error in the extension backward, then definitely it would affect the value of FP. So that is the problem. Next, accuracy providing. Next point, Nagendra.
Accuracy providing the gross fuel consumption is difficult.
Fuel consumption
Speed
is
of an
difficult,
engine may
isn't it?
vary.
Wait a minute. Give me a time after one point, Nagendra. What is it? Huh?
Okay.
Just give me a time, okay? So gross fuel consumption exact ಆಗಿ ಕೊಡೋದು ಕಷ್ಟ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾಕೆ? Suppose engine ಇದೆ ಒಂದು, there is an inlet valve. You have set it to 2%. What's guarantee that only 2% of the fuel is going? We cannot monitor that level of accuracy for the fuel consumption, isn't it? So that is one of the problem. Next, the speed of the engine may vary during the process. Correct, Nagendra?
Sir, speed of an engine may
So
vary
during the
during the process.
one thing remember, while going out with the Williams line method, the speed of the engine should be constant. But maintaining the speed of the engine constant is again a difficult task, isn't it? Last point, Nagendra.
The slope of the curve may vary when different types of engines are considered.
Definitely. So different types of engines in the sense we have studied about the different types of engines, V engines, rotary engines, opposite engines, variety of engines we have studied. The slope for the V engine could be something like this. The slope for a horizontal engine something like this. And the slope for the vertical engine could be something like this. So it all varies. So again, its slope is vary. Extending it backward again creates a problem, isn't it? And it affects the accuracy. So that is how this Williams-Lines method is not so convenient to calculate the value of FP. Any doubts in Williams-Lines method, guys?
No, sir.
Good. The next is the motoring test. So as Williams-Lines method is having a many amount of issues in it, so what we'll be doing is we'll be going with the motoring test. So how the motoring test is done, can anyone take up this task? Just read the content whatever you have. Don't add a comment. Kindly don't add a comment onto a cell, Muhammad Munawar. Okay. Can anyone just take up this task and read it and just explain me the same thing? Anyone? Anyone understood how it is done? Chant? Mohan Chandra? Marvan? Any idea, guys?
Yes, sir.
ಹೇಗೆ ಮಾಡ್ತಾರೆ ಮರವಿನ್? ಮೋಟರಿಂಗ್ ಟೆಸ್ಟ್
ಸರ್
ಹೇಗೆ
ಅದು
ಮಾಡ್ತಾರೆ?
ಅಲ್ಲ ಸರ್, ಅದು ಮನೆಯಲ್ಲಿ ಇಲ್ಲ ಸರ್, ಅದು ಚೂರು ರೈಲ್ವೆ ಸ್ಟೇಷನ್ ಬರ್ಲಿಕ್ಕೆ.
ಅಲ್ಲ ಕಣ, ನಾನು ಕೇಳ್ತಿರೋದೇನು ನೀನು ಹೇಳ್ತಿರೋದೇನೋ?
ಹೌದು ಸರ್, ನಾ ಅಂದ್ರೆ ಮನೆಯಲ್ಲಿ ಇಲ್ಲ ಸರ್, ಅದು
ಮರವಿನ್,
ಕೇಳ್ಲಿಕ್ಕೆ ಆಗ್ಲಿಲ್ಲ ಚೂರು ಕ್ಲಾಸ್.
ನೀನು ಊರೆಲ್ಲ ತಿರುಗ್ತಿಯಲ್ಲೋ ಕ್ಲಾಸ್ ಇಟ್ಕೊಂಡು?
ಇಲ್ಲ ಸರ್, ಅದು ಚೂರು ಟ್ರೈನ್ ಟಿಕೆಟ್ ಒಂದು ಕೇಳ್ಲಿಕ್ಕಿತ್ತು, ಅದಕ್ಕೆ ಬಂದದ್ದು.
ಇವೇ ಕ್ಲಾಸ್ ಇದ್ದಾಗ ಮನೇಲಿರು, ಇಲ್ಲ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಇರೋ ಒಂದ್ ಕಡೆ ನೆಟ್ಟಕ್ಕೆ ಕುತ್ಕೋ, ಕೇಳು ಕ್ಲಾಸ್ನ.
ಹೌದು ಸರ್, ಆಯ್ತು ಸರ್. ಅದಂದ್ರೆ ನಾ ಮೈಸೂರು ಹೋಗ್ಲಿಕ್ಕೆ ಉಂಟಲ್ಲ ನಾಳೆ, ಅದಕ್ಕೆ.
ಏನಕ್ಕೆ
ಅದು
ಮೈಸೂರಿಗೆ?
ಅದು ಇದಕ್ಕೆ ಸರ್.
ಹಾ, ಸರಿ ಸರಿ ಸರಿ, ತೊಂದರೆ ಇಲ್ಲ. ಓಕೆ, ಆಲ್ ದ ಬೆಸ್ಟ್. ಹೋಗಿ ಬಾ.
ಥ್ಯಾಂಕ್ ಯು.
ಈಗ ನೆಕ್ಸ್ಟ್ ಯಾರನ್ನ ಕರೆಯುವ? ಪ್ರತೀಕ್, ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀಯ ಪ್ರತೀಕ್? ಹೇಗೆ ಮೋಟರಿಂಗ್ ಟೆಸ್ಟ್ ಮಾಡ್ತಾರೆ ಅಂತ? ಪ್ರವೀಣ್? ಪ್ರವೀಣ್ okay, kindly observe this. Now I'll be explaining how this particular motoring test occur. Okay, so engine ಇದೆ ಒಂದು, and this particular engine is rotating this particular shaft. Okay, correct? Now, na en ಮಾಡ್ತೇನೆ, I would connect a dynamometer. Dynamometer. So dynamometer is something like this. Suppose if there is a dynamometer, okay, and it has a shaft like this, okay, and there is a current cable for this, okay, power supply. Suppose if you turn this particular shaft, kindly understand this, if you turn this particular shaft, the electricity would be produced. Okay, electricity would be produced. Dynamo, it acts as a dynamo. Now, on the other hand, if I give the electricity, this particular shaft will rotate. That means now it is acting as a motor. Got the concept, everyone, about the dynamometer?
Yes.
Correct? So either of the way is possible. If we give you the shaft power output, electricity would be produced. On the other hand, if you give the electricity, shaft power output would be produced. So that is the funda. Okay, now what I'll be doing is, I would operate my particular engine, which is here. Okay, I would be operating this particular engine with certain amount of loading conditions. Okay, say I would be giving 50% of the fuel, okay, and 50% of the load, and speed I would maintain constant. Okay, I would just run this particular dynamometer. Okay, now what I would get? What I would get? Anyone?
Electricity.
Okay, kindly read this. You are not participating, that is my problem. Now you read as Sayyid Anwar. Sayyid Anwar.
Yes, sir.
Now you read this. Kindly read this.
Motoring test. Motoring test is also used to calculate the friction power. The engine to be tested in first run up
Tested.
to the
Yes.
desired speed and non-cooling a
Condition.
non-loading
Cooling,
condition.
known cooling
Non-loading.
at a known loading condition. So first what you have to
Non-loading
do,
condition. Yeah.
the engine is taken, and that particular engine is being loaded with a known loading condition, with a known speed and a known cooling conditions. Next.
The load is applied by means of dynamometer.
So load is applied how here? The load is applied by using a dynamometer. Next.
The engine is kept running until the stable conditions are reached.
So engine will be
Sir,
kept
what is stable
running
conditions, sir?
until the stable conditions, in the sense, when you operate an engine, your engine, suppose, for example, I would say, there would be a speed. Okay, speed irutte. 40, 50, 60, 70 km per hour ಅಲ್ಲಿ ಇದು ರೊಟೇಟ್ ಆಗಿರುತ್ತೆ. ನೀಡಲ್ ಇರುತ್ತೆ. ಓಕೆನಾ, ಈ ನೀಡಲ್ okay would be continuously wandering between 50 and 60. Say your needle is continuously wandering between 50 and 60, then you cannot say it as a stable condition. It is wandering, it is fluctuating. Suppose if you keep your accelerator, okay, for a constant condition, suppose if the road condition is constant, after some time, this wandering will shortly come and fix at particular point. Suppose the speed will be constantly maintained at 55. Yes or no? So if you keep your accelerator constant, okay, if the engine road condition is constant, if there is no slope, nothing, then automatically your engine speed will be colliding to 55. It will be stable at 55. Now you can say that the engine is in a stable condition. Getting my point?
Yes,
So
sir. Understood.
this I have just explained you only with respect to speed. It could be with respect to the cooling conditions also, the temperature also. Temperature will be continuously fluctuating. It has to be stable. Okay. Engine RPM, if it is fluctuating also, no, it has to be stable condition. So all those parameters, once it has reached stable, then you can say your engine is in a stable condition. Got the point, Khalil?
Yes, sir. Understood.
Good. So next one. Now motor drives the whole setup. So once the stable condition is reached, now what you'll be doing is, now you will cut off everything. Now you will cut off everything. Now you'll cut off the fuel supply. Once the engine reached the stable condition, what you will do? You'll cut off everything. You'll cut off the fuel supply. You'll remove the load from the dynamometer. Rather, what will you do? Just read by the sentence. You'll come to know. Yes, Anish Pinto.
Now motor drives the whole setup
Whole
to
setup.
the same
Yes,
to the
to the
some to same
same
okay to the
initial.
same initial condition.
Exactly. Just a minute, Anish. Just a minute. Okay. So now what you'll be doing? You're supplying the power. You'll be supplying the power to the dynamometer, where the engine is run in a reverse fashion. Okay. To the same initial conditions, in the sense, whatever was the initial condition, at which speed the engine was running, at which cooling effect the engine was running initially, at which engine RPM the engine was running initially, to that particular RPM, now you will get back the engine using the electric power which you supply to a dynamometer like this. Okay. Now, next point. By suitable electric switching, Anik, carry on.
By suitable electric cable switching, dynamometer
Hmm.
can be converted into
Can
a
be.
motor. Converted into
Very
a
good.
motor.
Next point.
In drive the engine at the same speed with which it was running previously.
Previously understood. Understood this point, everyone?
Yes, sir.
Yes, sir.
Good. So now the miracle thing is, whatever current is being consumed, we'll be having a meter, isn't it? How much current is being consumed there? And this particular amount of power, what it is being consumed now, is nothing but your brake power. Got it? How you will do the motor test to calculate your brake power? Any doubts?
No, sir.
Okay. Next one, limitations. Limitations, anyone? Aditya Shetty?
Yes, sir.
Limitations?
Load due to motoring is not same as engine load, as it imparts various unbalanced loads on bearing and other moving parts which is not accounted.
Which is not accounted. Why? Because, see, okay, this is not brake power, this is frictional power, what you will get. Okay, so this is frictional power. Now, while running an engine, while running a motor, it is totally different concept. Running an engine, in the sense, there will be most knocking will be happening, piston will be rotating, I mean reciprocating. Okay, there will be most number of unbalanced forces. Whereas in the motor, it will cleanly rotate, isn't it? There will be no unbalanced force in case of a motor. But whereas coming to an engine, it would be having a many number of unbalanced forces which is accounted. So again, there would be a mismatch in the values. Next point.
Suction and compression are work given out by system on engine which are not accounted during motoring.
Accounted for the motoring. So what happens out of four strokes? Okay, out of four strokes, what are the four strokes? Anyone? Suction. Next stroke is
Compression,
what?
Compression, combustion, exhaust.
Compression. Next one is
power stroke, expansion,
power. Next one is exhaust.
exhaust.
So out of these four strokes, okay, only power stroke is a source of power. That means only in the power stroke, the engine would give the power to the crankshaft. Okay, only in the power stroke, engine would give the power in the crankshaft. On the other hand, remaining all these strokes, suction, compression, and exhaust, for all these strokes, the flywheel or the crankshaft will give you the power for the engine. Correct? For all
Yes,
the three remaining strokes. So that particular phenomenon is not being accounted in case of a dynamometer while operating a motor, isn't it? Definitely there will be a mismatch in the values. That is one of the limitation. Next one.
During exhaust, back pressure is on the crankshaft, which is again not accounting in
Crankshaft.
motoring.
Not accounted in the motoring. So during the exhaust stroke, what happens? So what is with the exhaust stroke, guys? So if there is an exhaust stroke, if it is if the gases are expelling out of exhaust port like this, if the gases are going out of the exhaust port, what will do? While it is going out, it would in turn push the cylinder backward. Correct? There will be a back pressure because of the exhaust gases which are going out. So that particular effect is not being considered in case of a dynamometer while operating it as a motor, isn't it? Last one. Last one gives the
Mo-
conclusion.
Motoring method, however, given reasonably good results and is very suitable for finding the losses due to various engine components.
So, however, while compared with Williams-Lines method, motoring test will always give you the good amount of accurate values, I can say, when compared with the Williams-Lines method. The last and a very important test or a method to find out the indicated power is the Morse test. How many of you heard about the Morse test? I think most of the diploma guys will be aware of the Morse test. Am I right? Menden Karthik,
Yes, sir.
Nagendra.
Yes,
So,
I
have you
know,
heard
but
about the
I
Morse
not
test?
remember. I heard,
You
I
don't
not remember,
remember.
sir.
You don't remember it. Okay. What about Menden Karthik? I think he's not there. We'll mark him absent. Okay. Menden Karthik. Okay. Now, what I was telling? Ah, so what is motoring test? So in a Williams-Lines method and in a motoring test, which particular parameter did you found out? Yes. Which parameter did you find in the motoring test and Williams-Lines method?
Friction power.
Frictional power. So in the Morse test, which particular parameter are going to found? In the Morse test,
Indicated.
so in the Morse test, you are going to find the indicated power. Let us look into it. Morse test is used to find the indicated power of the each engine in a multi-cylinder engine. Remember, Morse test can be done only in multi-cylinder engines. If there is a single cylinder, then it is difficult to calculate using the Morse test. So how we are going to do this? Okay. In this particular test, the output shaft is connected to a suitable dynamometer. Again, the output shaft is connected to a suitable dynamometer. So what happens in the Morse test is, I think there is no space. Okay. I would use this. Okay. Here I will just. So this engine number one, I mean to say the cylinder number one, cylinder number two, cylinder number three, and cylinder number four. For all this, there will be a common shaft, correct? There will be a common shaft which is rotating. And this particular thing would be connected to a dynamometer. Okay, so this is how it is done. Kindly look into it. In a multi-cylinder engine, the first when all the four cylinders would be kept running, then you will note down the reading of a dynamometer. First, after that, firstly, look the sentence. Firstly, the first cylinder is cut off. So just add on to it, it is cut off. By taking out fuel injector plug. So there will be a flux, isn't it, for everywhere. For every engine, there will be a plug. So what you will be doing is, in the first stretch, you will be cutting off the engine number one. So now what you have done, you have cutted off the engine number one. As a result, engine speed will now drop. Eventually, when you cut off an engine, when you cut off certain cylinder, automatically the engine speed would drop, isn't it? Now, so it is made by using a dynamometer to bring back to its original speed. Now, the BP, whatever you calculate using a dynamometer, would be taken as the value of BP1. Similarly, now the engine 1 is put forth. Okay, the connection is being given for engine 1 and engine 2 will be cut off. Similarly, you will calculate the value of the BP2 and you will repeat the process for the engine number 3 also. So engine 3 is being given, engine 2 is that, and engine 3 now will cut off. Similarly, you will calculate the value of BP3 and then you will calculate the value of BP4. So what is BP1, anyone? So what do you mean by the value of BP1? It is the brake power when the engine 1 is cut off, correct? Nagendra, what do you mean by BP2? What do you mean by BP2?
Engine
It is the brake power
power which is
when engine 2 is cut off. Okay. Numan Ahmad, what do you mean by BP3?
Sir, it is the brake power developed by the cylinder 3.
When engine 3 is cut off. Okay. The same procedure. Okay. Now I will read out the sentence. Hope you are clear about this. I would just revise this off. Okay. Now, same procedure is carried out to calculate the value of BP3, the value of BP4, and so on. Okay. Now the total brake power is BP1 plus BP2 plus BP3 plus BP4, isn't it? Now, BP1, can I write it as IP1 minus FP1? Can I write it as such?
Yes.
Correct?
Yes, sir. Correct.
So similarly, what I will be doing is I will be writing BP1 as IP1 minus FP1, BP2 as IP2 minus FP2, BP3 as IP3 minus FP3, and BP4 as IP4 minus FP4. Once I have written this, I would just bring all the IPs on the one hand and I bring all the FPs on the other hand. Just the rearranging of the terms. Okay. So it would be IP1 plus IP2 plus IP3 plus IP4 minus FP1 plus FP2 plus FP3 plus FP4. Okay. Now, when the first cylinder was cut off, this is very important, guys. just remember this. When the first cylinder was cut off, as in the figure, do you think the IP, the indicated power, would be developed in that particular engine?
No, sir.
Definitely not. If you remove the fuel plug from that particular engine, definitely IP1 is nothing zero there because you're cutting off that particular engine. So removing IP1 from this particular list would change the value to be BP1. I said, what is BP1? BP1 is the brake power of the engine when the first cylinder is cut off. So I could say it is, first cylinder is cut off in the sense IP1 is being eliminated, so therefore BP1 is nothing but just IP2 plus IP3 plus IP4 minus FP1 plus FP2 plus FP3 plus FP4. Now, what you do is, if you subtract equation number 1 with equation number 2, what you would get, all this IP2, IP3, IP4 would cancel with IP2, IP3 and IP4, and FP1, FP2, FP3, FP4 would cancel with FP1, FP2, FP3, FP4, and whatever has been remaining, I have written it here. Okay, there's nothing, something like this. Okay, so BP minus BP1 is nothing but IP1. So this is how you can calculate the value of the IP for the first cylinder. This is how we can calculate the value of IP for the first cylinder. Similarly, when this for the second cylinder, it is BP minus BP2. For the third cylinder, it is BP minus BP3. And for the fourth cylinder, it is BP minus BP4. Okay, so once you calculate IP1, once you calculate IP2, once you calculate IP3, and once you calculate IP4, if you add all these values, then it will give you the total indicated power of an engine. So this is how, by the Morse test, we'll be calculating the value of indicated power. Okay, if you seem to be confusing, if it has seemed to be very lengthy process, definitely it is not. It is very, very easy. Once you solve the problems on it now, definitely you will feel comfortable. Any doubts in this?
No,
Any doubts, guys?
Okay.
Okay. Okay. Next is octane number and cetane number you have, engine fuels we have. This we will discuss in the last class, next class, okay? I think a few more minutes are there. We will take up this and finish it off so that in the next particular class, you can directly start with the problems, okay? So octane number, what do you mean by octane number? So octane number, this you have to by heart, guys. This is very, very important. They would ask it in the form of definitions. The octane number is used for the petrol engines, remember this, and the cetane number is used for the diesel engines. Okay, what is this octane number and what is the cetane number? This particular octane number will give you how much knocking does one kind of petrol gives you. Suppose if the octane number is 30 and the octane number is 80. Okay, 80, if octane number is 80, then you can assume that gives you the more amount of knocking. If the octane number is 30 or below, you can assume that the knocking, whatever is present with the petrol, would be very, very less. So this is how the octane number and the cetane number are being used to know the knocking characteristics of diesel and petrol. So how will you come to know this octane number and cetane number? So it is nothing but it is a percentage of isooctane. It is a percentage of isooctane in a mixture of isooctane plus normal heptane. Okay, that gives you the same knocking intensity as the fuel whose knocking is to be calculated. So how it is done, it is a little bit tedious, guys. I will just explain you, just try to remember it, or else by heart it. Okay. So now what I would do is, see, I would just explain you this. Initially what I'll be doing is, I would take isooctane and normal heptane. Kindly concentrate on this. Okay. Initially, I would give 0% isooctane, 100% normal heptane. Next is 20% isooctane, 80% normal heptane. Next is 40% isooctane, 60% normal heptane. Okay. Now, other is 60% isooctane, 40% normal heptane, 80% isooctane, 20% normal heptane, 100% isooctane, 0% normal heptane. Now for this, I would know the knocking characteristic. Okay, I would use 0% isooctane and 100% normal heptane. I would come to know the knocking intensity. I would know the knocking intensity is 100% here. Okay, and similarly, I will note down the knocking percentage of all the things. So how much knocking it is being given, 40% and 20% and so on. Now I know if I go with 40% isooctane and 60% normal octane, I would get the knocking intensity as 60%. Similarly, if I go with 80% isooctane, 20% normal heptane, I would get the knocking intensity as 40%. Getting my point? Now, I would take some random petrol. I would take some random petrol. I don't know what is its knocking characteristics. Okay, I don't know what is its knocking number. So what I do, I take this petrol and generate the knocking intensity. Okay, I would generate the knocking intensity. Now, if the knocking intensity is 40%, now if I got the knocking intensity to be how much? How much?
40.
40%. Now I will go back to here. Okay, knocking intensity is 40%. So the percentage of isooctane is 60. Therefore, octane number. Therefore, the octane number of this particular petrol is 60. Okay. Another example. Now I would take another petrol. Now I would take another petrol. Okay, which has, I will give it for the test and I will come to know the knocking intensity is 80%. Now what I have to do to know the octane number of this petrol? I have to go back to this particular chat, look for 80% and come back here and look for the percentage of isooctane. So now, according to you, what would be the octane number of this particular petrol? It would be 20.
20.
Correct? Correct? And last example to make you understand, okay, I would take this color now. Now I would take a petrol whose knocking intensity octane number has to be found out. So I would just check the knocking intensity. I got it as 60%. Knocking intensity, I got it as how much? 60%. Now what I have to do? I have to go back to the already prepared chart, check for 60%, which is here, and check for the percentage of isooctane. How much it is?
40.
It is 40. So what is the octane number of this particular petrol now?
40.
What is the octane number? 40. Understood everyone how to calculate the octane number?
Yes, sir.
Understood? Everyone? So how many of you understood? Just raise your hands. Let me check how many of you are alive. Good, good, good. Very good. So this is how you calculate the octane number. I'll just leave this diagram as it is here so that you can have a diagram idea. Now, can anyone just read this to understand the octane number? Ritik, can you just read it? It is a percentage of. Ritik,
It is the
good.
percentage of isooctane in the fuel
Yes.
containing isooctane and
Containing isooctane and normal heptane. Yes. Next. Next.
fuel whose is
That
calculated.
gives same knocking intensity as that of the fuel whose octane number has to be calculated, as that of the fuel whose octane number has to be calculated, in the sense the sample piece which you have taken. Got it? Everyone understood how to calculate octane number?
Yes, sir.
Very good. So this particular octane number is used for the petrol. Similarly, when you go for a diesel, you will use same principle you'll be using, but here you will be using the mixtures differently. Different mixtures will be used. Here you will use one as cetane. So one chemical is cetane and other is alpha methyl naphthalene. So these two chemicals, alpha methyl naphthalene. Okay, so between these two chemicals, again you prepare a chart and know the knocking intensity, and again come back whatever the petrol diesel has to be tested, that particular knocking intensity, note it down and come back reversely to know the cetane number. So cetane number is calculated for the diesel and the octane number is calculated for the petrol. So I will just read it out, just try to understand this. It is a percentage of by volume of cetane in a mixture of cetane and alpha methyl naphthalene that has same performance in the standard, same performance in the sense, same knocking intensity in the standard test engine of that of the fuel whose cetane number has to be calculated. Suppose if there is a sample piece whose cetane number has to be calculated, if it has given the cetane knocking characteristics as 40%, then you go back to the chart prepared and note down the percentage of cetane, you'll get the cetane number. Getting it? And this is the relationship between the octane number and the cetane number, where it says cetane number is equals to 60 minus octane number divided by 2. Just note down this particular value also. And engine fuels and all those stuff, you'll look at in the next class. It's already been late. Okay. Thank you, guys. So hope you have marked your attendance. Take care. We'll meet up in the next class.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.